audio. Can you hear it now?
There it goes.
Okay, sorry about that. Whoever was trying to listen. That's bad. It's probably why it's good to have two people rather than one. Yeah, so in this web application, you can register, create an account, and it has some vulnerabilities that are like, you can register with the word test as your password, and add stuff to your shopping cart, and then you can go and buy things. Luckily, I've already got my credit card pre-filled, nice and handy. Cool, so that's the application. So the bit that's vulnerable to SQL injection on this is the search query. So you can see how I search for ghost, but if I search for A, I would get all the items that have an A in them. But if I search for A or 1 equals 1, it's going to join it into an SQL statement, which is always true, and select all the products in my database. So it'll be a longer list. That's probably not so easy to see. So that's got the one that's got Go script plus all the other ones. And that's because my application is trusting what the user's typing in and then passing it all the way to the database server to run. So why is this a big deal? Well, there's a nice handy tool you can run called SQL map, SQL map. And what this does is it looks at, you give it the input you want it to play around with, and it'll pass it different data and look at the output and figure out basically all the rows in your current table. And then it will start doing more complex queries to union with other tables to find out which tables exist, and then all the rows from those tables. And you can see here SQL map has figured out that what kind of database it is, figured out some queries, figured out all the tables in my database, including ASP.NET roles and users, and then started dumping the tables just by unioning it to the products table and getting all the columns out. It took it, somewhere it says how many requests it took. Yeah, I don't know where. It took it like hundreds of requests to do that, but if no one's watching, you can suck all the data out. And what you end up at the end of it is just a bunch of CSVs containing the data and all the tables in my database. So essentially, SQL injection is pretty much the worst thing that can happen to most websites. And there's always examples of them in the news. So what should you do about it? Well, as I was saying, SQL statements combine code and data. So you should separate your code from your data. So the user's input you should treat separately from your code that you want to send to the database server. And so you can go and read more about this, but parameterizing your queries, so putting question mark or @ parameter name, validating what they can enter. So if it's a numeric field, don't let them enter words. Escaping special characters if you really have to, but probably parameterizing your queries is the best option. That's number one. Any questions on injection? Oh, I ripped right into it. Okay, so authentication issues. These are more like logic issues that are happening in your web application's code itself. And these are the sort of things where your web application's not keeping track of who's logged in properly. Like maybe it's using a cookie to keep track of who's logged in, but the cookie just has a number in it or a username in it. Maybe it lets you try lots of different usernames or passwords, which is called credential stuffing, when you download a list of common passwords or compromised passwords. Brute force, where you just try random ones. Or maybe some other parts of the application don't work, like when you reset your password, there's some weaknesses in there that let you reset other people's passwords, or sessions don't expire. So if you want to prevent authentication issues, the number one thing probably is just to not write your own authentication system and to use a library that's good. And if you come to the conference next Friday, there's a talk on improving identity management with W3C verifiable credentials, which sounds like a nice approach. But I haven't been to the talk yet because I'm not a time traveler. But you know, if your platform has an authentication library, read up on whether it does it properly and use that probably in preference to writing your own. If you only use passwords, then you should enforce that they're strong, but you should also consider using multi-factor authentication, such as a Google Authenticator, and you should detect attacks when they're happening. So, you know, like in that SQL injection, it took hundreds of requests. If someone was logging that and looking at the logs, maybe you would detect it and stop them when they only had half the database instead of all of it, and the same thing with this. Cool. Number 3, sensitive data exposure. So this sort of hits 2 parts of your application really, is how data gets to and from your website, between the user and the website, and how you store data and whether it can leak out of your system. And A3 kind of covers both of those. So these days, not many web applications just use HTTP. Most of them are HTTPS, which means that, you know, someone else in the cafe or in between you and the web server can't read what you're doing as easily. So HTTPS, obviously, maybe your storage isn't encrypted on your servers and there's a break-in in your office. Maybe someone left the door open, just put a table to block it. Maybe you are encrypting stuff, but the encryption is weak or the keys are public, checked into GitHub. Maybe you're not checking certificates, so someone can put a fake web server up and people can use it and capture the information, or other information might get exposed. So we see kind of like data leaks, data exposure quite often in the news. I think there's been a few in New Zealand recently. I'm trying to think of some Wellington-based health organization.
Yeah. And there's that kids Moldy ceremony thing. They put the passports on like a web site.
Yeah, yeah. So I mean, this happens in New Zealand. It happens everywhere. So what should you do about it? Well, if you see not secure on a website, it's normally not a good sign, because that means that the data is not encrypted between you and the web server. But also, like, just think about what information you have stored. So I'm logged in as test and I can see my order. It says pay by credit card for and then 15 ones. But if I change the URL, maybe I can see other people's orders, like Joe Blogs, and see, oh, he's actually got the same credit card as me. That's funny. You know, like, maybe we shouldn't be storing credit cards, because then there's nothing to leak. If we don't need Joe Blogs' age, maybe we don't store it, that sort of thing. So yeah, don't store data unless you need to. Encrypt data at rest and in transit. So by encrypt data at rest, that means when you're storing something in your database, use the database's encryption. So either the hard disk encryption layer or the SQL Server data encryption or whatever, so that if the database gets stolen, the server gets stolen, the data is not accessible. And also when you're backing up data, make sure that you back it up encrypted. Don't just do a MySQL dump and put it on an S3 bucket, because people always find them. And use strong crypto. So I'm not going to go into this because this is like a whole talk, but whenever you're picking ways to encrypt data, there's like 1,000 ways to do it wrong and 1 way to do it right, because the internet is filled with bad advice and has been around for 20 years and state of the art has moved on. So normally it's safer to use someone else's libraries to do cryptographic stuff and to find some best practice information. There's also 2 talks next week. One is called Why Randomness Matters, which I assume we're going to be talking about random numbers and cryptography. And the other one is Nick's talk, which is about cooking with salt. Is that right, Nick? Yep, cool. So hopefully you come along to those. Cool. So number 4, I'm just going to keep going if no one asks questions. XML external entities. So this is another one that affects your web server's logic. And this is if your website is accepting XML, which is a pretty common thing to do in the early 2000s. But now we're all like YAMLing and JSONing and stuff. Yeah, no, we still use XML everywhere, of course, because nothing ever dies in this industry. But there's like a few gotchas around receiving XML that you don't trust and processing it. So if your application accepts XML and assumes it's safe, it might let the person that's uploaded the XML declare their own doc type. And in the doc type, they can do this thing called an external entity where they reference a file on your server. So the files, etc., password, the XML, when it loads in your web application, will load, etc., password before processing the XML. It could also reference a URL, so like HTTPS blah, 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 and then that might access one of your internal systems that you don't think is on the internet. I think another variation of XML attacks allows you to execute commands. And so attackers can use this to get AWS secrets out of files or off the metadata service. They can use it to run things on your web server, and also denial of service, blow up your memory. So I'll give you an example of that. So my website has 2 APIs, of course, one in XML and one in JSON, because JSON is hip and new, and XML is old and B2B. And so I've just got this little API browser thing where you can type in some XML and send it to the server, and then you get a response back, and it just tells you whether your order's shipped. Here's a little clue. I'm a lazy programmer. Every order has shipped, so it's just like being on TradeMe. Yeah, no one ever sends stuff but sells you they have. So here's just 2 different XML attacks. So this one is called the billion laughs attack. And so in the XML that I'm sending to the web server, I'm referencing &A4, which is an entity that I've defined. And &A4 is 10 &A3s. &A3 is 10 &A2s. &A2 is 10 &A1s. And A1 is 10 lols. I don't know if they're actually 10. But you can kind of get the 1 A4 should be 10 times 10 times 10 times 10 lols, I think. And so when I send this request to the web server and it does some processing, it says that my parcel lol has been shipped. And this is a denial of service kind of attack, because I only have to go up to about, I don't know, 10 before it's like, I don't know, every atom in the universe or something. I don't know, I don't do maths that well, but you know, it's pretty easy to exhaust the memory of your web server. Another kind of XML attack is that external entity one where you put in a file reference. And so now when the web server wants to see which parcel I'm looking for, it looks at that etc. password file on my web server to find out. And that's the etc. password. So, I mean, that's not that exciting because it's just a Docker instance. But, you know, there's probably other stuff on my web server that is interesting, and I can just type any path in there to find it. Yeah, so XML, more of a hassle than you'd expect. So, yeah, number 1 recommendation. Don't use XML. If you do use XML, use modern libraries. So I was previously a .NET developer. It's like 4 different ways to parse XML. I think there's like XML reader, XML document, XML text reader, XML document 2. I can't remember what they all are. And some of them are like 20 years old and some of them are 2 years old. So you want to figure out which is the one that is more modern and more configurable. And then you want to turn off external entities and some of the other features. And most modern libraries will turn them all the insecure things off by default. You have to turn them on if you want to take the risk. And the other option you've got is to validate your XML. So maybe look at what it looks like, check it's in the right structure before you parse it. Unfortunately, that sounds like parsing something before you parse it. So your mileage may vary. You might end up just moving your problem up one level. And at the conference next week, Karan is talking about different attacks. One of them is about XML entities. So go into that a bit more. Any questions at this point? Cool. Okay, continue the whirlwind. Broken access control. This is another issue in your application where you might not be enforcing access to sensitive information. And the really common one is having admin sections of your site where the menu hides the option to go to admin if you're not an administrator, but the URL still works. And that's like my site here. There's actually an admin section. If you go admin/orders, and you can see everybody's orders, but it's just hidden from the menu because I'm not an administrator. But it also could be like business logic style issues that let you elevate from one account type to another. Maybe viewing other people's data, like we did in that shopping cart where I saw someone else's credit card just by changing the URL. And this happened, I think Z Energy had a loyalty scheme or a fuel card scheme, and you could look at the URLs and see other people's addresses and stuff. There was a bank in Australia. Someone reported to them that he could change the URL, see other people's bank details, and they sent the police to his house and confiscated his computers, which seems a little extreme. Or if you're using cookies, maybe the cookies or the tokens to log into your site can be manipulated. Like if your cookie just says admin equals true, maybe someone could, admin equals false, they could change it to true. So again, using proven libraries, denying access by default. So there's sort of two ways you can write an if statement to test if someone's an administrator. You can say, you could deny everyone, and then if they have an administrative role, allow them through. Or you could allow everyone, and then if they don't have the role, you could let them through. And sort of if you deny by default, your code path is much less likely to have bugs. I didn't explain that very well. Anyway, whatever, you'll figure it out. That's why you came, right? You'll figure it out. Logging failures and alerting. So there's a whole bunch of like use cases that your application never intends should happen. Like no one should ever be fiddling with cookies or changing the URL to see other people's information. But if you're logging that when someone does it, then your bank's like, that's weird. Kirk's logged into his bank account and he's trying to change the URL to see other people's accounts. Maybe we should just give him a friendly call and remind him of our acceptable use policy. And another thing you can do is rate limit access. So if you don't expect anyone to view their account transactions in their bank account 1,000 times a day, maybe you could cap it at like 20. And so then if you do have a vulnerability somehow, at least they can only steal 20 people's worth of data per day rather than your entire database. Yeah. Okay, security misconfiguration. Now this is quite broad, and there is on the OWASP site, sorry, I forgot to mention, so I'll mention it now. When you go to the Top 10 project, there is a PDF you can download which goes into more information, and a 6 security misconfiguration has a whole bunch of different examples, but pretty much anything you can configure in your network, on your servers, and your web applications, you can also misconfigure. There's kind of like a million different ways you can do it. But some common ones are leaving features turned on when you're not using them. So if your application, I don't know, doesn't need to log in, if your users don't need to log into the admin section, remove the admin section from your website. If you're not using NTP on your Windows server, maybe disable that service, that sort of thing. Also default accounts. So like if the default account for a WordPress install is admin, maybe you should delete that after you create your own admin account with a better username that's unguessable. or if your firewall router, I don't know what the default password for firewalls is, probably admin. You should probably change that or delete the admin account. And then the other thing that people sometimes do is expose sensitive information in their error messages. I can't remember if my website does that. I'm sure it does, whether intentionally or not. But you know, sometimes you'll see a website, instead of a friendly message like, sorry, an error has occurred, please call our contact center, it'll say, you know, org.mycompany.something Java exception and blah, 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 and then dump a whole bunch of database information. And so you want to make sure that you don't have any of that enabled, that you disable that. So prevention on this is hard because it's like do everything properly. But one way that works for people is to have like a gold master build that they use for their web servers. So maybe you have a hardened Ubuntu install, and you use that to create your like gold Docker image, or you have I don't know, your perfect install of Windows NT4 and you zip that up onto floppy disks. However you build your servers, have your hardened version of it and then use that. And you can actually get tools to review your servers to check if you've got any services running that you don't realize, any ports open, that sort of thing. And Jeremy has this fun talk next week as well on SSH certificates, which in my experience not many people use, but are quite a fun way, SSH, I don't know, your mileage may vary, but are an interesting way of locking down your SSH to make it a little bit harder for people to get in. Cool, okay, I'm going to pause for a sec. Questions from Nick?
Not so much a question, just a recommendation. If you're using AWS, is AWS Trusted Advisor. That will tell you if you've got things misconfigured. And same with Azure, there's Azure Security Center. So if you haven't checked out those pages and you're using those services, they're really good for that type of issue.
Nice, good recommendation. I'm pretty sure the mic will have picked that up. While I'm pausing for break, I bought these books ages ago using the OWASP chapter's money, but forgot to give them away for prizes. So instead, I've made them library books. So I'll just pass them around. If you want to borrow it till next meetup, you can. Tangled Web, I can post the link. You can buy the PDF from it, normally pretty cheap, Humble Bundle or something like that. It's 5 years old, but it's a really good breakdown of how browser security works. So sort of like the left-hand part of that picture. So yeah, if you want to pass them around, and then just whoever wants to take it home, keep it. And then the people at the back, sorry, you should have sat at the front. Then pass that around. Cheers. Okay, cross-site scripting. So this is kind of like the big one. Now, it's only ranked number 7 because the severity of a cross-site scripting issue may be not as bad as SQL injection, but every application has cross-site scripting issues. Like web applications just have them everywhere. And the areas that kind of affects is the DOM, so the HTML and CSS, and the JavaScript that's running in the user's browser. So it's kind of less of an issue on the web server and more of what's happening in the user's browser. So I'll try and quickly explain. So just like SQL statements, HTML mixes multiple things into one big string. So when your web page loads, it's got HTML, which is content, paragraphs and stuff. It's got CSS, which is presentation, and it's got JavaScript, which is code. And you want your code to run in the user's browser inside the context of your website, and you don't want other people's code to run there. And the reason for this is that any code that runs in the context of your site can do anything that the user can do. So if you can get JavaScript to run in the user's browser inside the context of site.a.com, it can spider through site A, delete things, add things, copy them out, proxy, all these kinds of nasty things. And if you want to see some examples, you could have a look at a tool called Beef, which is probably not that easy to Google. Maybe if you Google for beef XSS, you'll be more likely to find it rather than the New Zealand beef industry. But yeah, so XSS is kind of painful when it happens. But it's attacking the user's browser and then using their browser to do what the user could do back against your server. Or in some situations, you're attacking other users. So if I can put information onto a website that then gets run in other users' browsers, will run. So yeah, so basically like HTML browsers, they're kind of a minefield of problems because we don't separate the stuff that's code from the stuff that users enter, that's data. And it's also quite easy-ish to find cross-site scripting, like compared to the other vulnerabilities. This is quite a mature market of paid-for services and hacker tools for finding cross-site scripting. So I'll just give you a demo. I actually unintentionally gave you a demo already. So yeah, see. So my little application lets people add comments like, this is the best WPIG exploit ever. Because social is the most important thing to have in a modern web application. But unfortunately, my application is not making what the users enter safe. So if the user enters the script alert hi script tag, I don't know if you can see that. If the user enters a script tag, then anyone that goes to this web page is going to run the JavaScript in their browser. So that's kind of like the canonical example, like an alert tag. And the particular place it's showing up in my browser is here. So if I look at the HTML at that point in my browser, you can see how there's, you know, when the website's displaying this text, it's just putting the script in as HTML script tags. So why is this bad? So like I said, that script tag could do anything that the user can do, which is not ideal. And, you know, alert box doesn't seem that scary, but, you know, scraping the website, stealing the credit card numbers, placing orders, transferring funds in their bank account, anything the user can do while they're logged in, the script can do. So, yeah, it's quite a common issue. And there's like whole talks on cross-site scripting. You can go back and look at our back catalog of videos, or we'll do a talk over the next year on cross-site scripting. But the main recommendation is to encode everything that users supply to make it safe. And that means instead of putting angle brackets when you display it, turn it into ampersand LT semicolon. So that's HTML encoding. But unfortunately, on a web page, there's HTML, there's attributes, there's URLs, there's JavaScript, JSON, JavaScript string. I don't know, it's probably some XML stuff. All of those need to be encoded in different ways. So when you're building a web application, you need to think about, okay, I want to display Kirk's first name. Am I going to put it in an HTML place? Then I need to use HTML encoding. Am I going to put it in an alt tag on an image? Then I need to use attribute encoding. So it's kind of a pain in the ass. And so choosing the appropriate encoding is a pain. So the modern way, I believe, of dealing with cross-site scripting is to use a templating library that does it for you. Does anyone have good examples?
Angular?
Is it good?
Yeah, Angular, the latest one, is good.
Cool. Yeah, I don't know, my dev knowledge is a bit behind, but yeah,
I think React as well is pretty good. Yeah.
Cool. Yeah, so anytime you're joining strings together, you have to think about, like, how am I going to do this safely? And if someone else has already thought of that, then it's not your problem, or at least it's your problem still, but you don't have to think of the solution. And then another solution is to use content security policy. And if you're starting a web application from scratch, it's the perfect time for you to learn about content security policy. And this guy at last year's OWASP conference gave a great talk on it that you should definitely listen to. His name was Kirk Jackson, and that's on YouTube. But yeah, there's heaps of information about there. When you're starting a new application from scratch, it's the perfect time to put content security policy in. It's a little bit harder to retrofit it, but you should probably still try. And the nice thing about content security policy is it allows you to separate your JavaScript from your HTML and mark which bits are supposed to be run in the user's browser. Cool. Questions? Okay, awesome. Okay, we're on the downhill stretch. How am I going? Oh, 40 minutes, damn it, too slow. So deserialization attacks. So these are a little bit weird, and you'd think they weren't that common, but actually there's been a bunch of reasonably high-profile web frameworks that have had this issue. And this is sort of an issue often in the framework you're using, but sometimes you can introduce it yourself in your application. So when you've got like a tree of objects in memory, like if you've got an object-oriented language, you might have a person, and what would people have? They'd have some attributes like their name and stuff, and they might have some sub-objects like legs and arms. Okay, this analogy is not working. You might have this tree of objects, and you want to send it to the user's browser, maybe in a cookie, or you want to send it from one application to another over an API call. One way you can do that is to use a serializer, which takes your object tree and turns it into a machine readable format, either binary or JSON or something else. And then the thing on the other end of the connection can deserialize it. The problem happens when you deserialize something that you don't trust or that you shouldn't trust, because some of these serialization formats let you specify which type of objects they are. So you might think that you're deserializing a person with 2 legs and 2 arms inside it, but the attacker might give you a serialized version of, I don't know, a file delete object or something like that. And so your code deserializes it, and now there's a file delete object in memory. So this is another example of not really being able to trust the data that you receive. I'll show you the demo of that. So I have an API which lets you search for things using JSON. This is basically just like a little wrapper, helps me write JSON that says search term as ghost. It sends the request to my server, and then it returns back, I don't know, an array of lists or however JavaScript works, some craziness. I'm using a JSON library that embeds type information in it, so that the thing on the other end can go, oh, this is a product. Okay, I'll deserialize that into a product object. But it also does it in requests. It also lets you embed type information. So here's one I prepared earlier, which is instead of putting the search term as letter E or the word ghost, I can say, I can look this up in iTunes. Well, that's handy. I can say the type of the object I'm giving you is a file system object. Here's the file name, and set read only to false. And when I send that to the web server, it returns an empty string, okay, or empty array. Maybe that's not so bad, but if I do a file that doesn't exist, then it says not found. So that's weird. It's like there's 2 different code paths. And so now I can figure out which files exist on the web server. So maybe I can see if etc. password's there. Oops. I don't know if it is there or not. I guess we'll find out. Yeah, so it is there. And so now I've gathered that information. I can use that for my other attack. But you know, that other attack where I could look inside files that existed on the file system. But if there's any C# classes that do destructive stuff when they get deserialized, then potentially even worse stuff could happen. And I really should know the details, but Rails had an issue like this sort of 5 years ago or so, where you could actually put stuff in your authentication cookie, and when the web application checked if you were logged in, it ran code on your Rails server. So you know, this sort of attack happens often when you do deserialization. And so prevention, well, you can avoid serializing and deserializing objects. So rather than just saying object serialize and object deserialize, maybe use a formatter that turns it into JSON that's safe. When you load the object, maybe check the structure on the way back in. You can sign the object, which is often what authentication cookies do. So you do a cryptographic signature and put that at the end. And if anyone tampers with the cookie, you can tell because the signature doesn't work anymore. Configure your library safely. So in my example, I'm using JSON.NET, which is actually a pretty decent JavaScript serializer, deserializer, and I had to turn off all these security features in order to get the demo to work. So you could, I don't know, not do that and leave all the security features turned on. And also the OWASP project has a nice cheat sheet. And so this is a good time to show you the cheat sheet section. Where people have, where is it? Cheat sheet series. People have done cheat sheets for a bunch of different scenarios that you might need to think about with some ideas of things for you to think of. So Docker security, there's some rules, injection prevention in Java, deserialization attacks. So that's a great resource for giving you a bunch of different things to think about while you're building your application. Cool. Number 9, using components with known vulnerabilities. Why would anyone do that if you know there's a vulnerability? Crazy, right? We all do it because our applications basically have this much of our code and this much of everyone else's code in them. You know, like not many people write kernels anymore to support their web applications. You know, you normally put it on top of someone else's. And it's hard to keep all that stuff up to date. And when it's not up to date, there'll be vulnerabilities and everyone finds out about them and attackers search the internet looking for that particular vulnerability. So if there's an issue with Apache 1.9, there'll be someone that writes a bot that scans for Apache 1.9 and it'll take on the order of hours to scan the entire IPv4 internet to find websites to dig deeper into. So yeah, kind of sucks to be us. And there's things you can do. So there's tools like this one, Anchor is for scanning containers. There's Retire.js, which will scan your JavaScript libraries. There's a bunch of these tools that will, you know, you point them at your Git repo or put them in your CI wouldn't it? Pipeline and scan your components to see if you're using anything out of date. But the main thing you have to do really is to budget for ongoing maintenance, because all of our projects were like, okay, I've finished that website, now I'm on to the next project. And a year later, when jQuery is out of date and has a vulnerability, no one wants to pay for jQuery to be updated, which is never as easy as it seems. I don't know, jQuery might not be that bad. I don't know if it changes these days. But you know, like JavaScript libraries change all the time and are often not backwards compatible. And so you need to budget in time to keep them up to date. The same thing with operating systems. So you've got a web server and it's running Windows NT4. Probably shouldn't be on the internet. Yeah, that sort of thing. Keep them patched. And lastly, the last recommendation, or the last, what do they call them? Vulnerability? No. Anyway, the last of the OWASP Top 10 is insufficient logging and monitoring. And this is, we sort of talked about this partway through the other ones, is that bad things could be happening on your website right now and you don't know. And if you were logging stuff and you had some kind of Splunk or a SIEM tool or Logstash plus, I don't know, Elastic plus Kibana or whatever, that would alert you that someone's changed their password 400 times today, or they've tried to guess the URL on a bank account 30 times, then you might be able to react. Of course, someone actually needs to be monitoring, so you need this person with this laser-like arrow out of their forehead to notice. And the first thing that happens is you put too much monitoring and that person explodes because they get 400 emails a second. And so finding the balance is quite hard. But yeah, without monitoring and without logging, you can't react to attacks as they're happening. And the other thing you can't do is to figure out what has happened. So say you find out that you've been breached, and your management's like, well, how did they get our data? And you're like, I don't know, didn't turn logs on. And they're like, oh, what about the web server logs? And like, the web server gets full, so we delete them every day. If you actually have your logging going off the machine onto somewhere permanent, then you have the ability to do some retrospective kind of proving who did something, perhaps. Cool. So that's the OWASP Top 10. Wasn't that exciting? It was a little bit fast. And what I think we'll do is do deeper dives into some of these areas and into some other areas of common web application issues, because obviously there's not just 10 things that can go wrong. There's as many things can go wrong as we can type code. But yeah, we'll dive into XML external entities, cross-site scripting, SQL injection, and other meetups. And also as next steps, you could go away and search some of these things for yourself. So there's lots of people who have recorded YouTube talks on, cross-site scripting in C# or Java deserialization attacks. So searching on YouTube, searching on Pluralsight or one of those training sites, if you've got money for it, or reading the cheat sheets on the OWASP site just to dig into some of these things. I think the nice thing about the OWASP Top 10 is it's kind of like the Gang of Four design patterns and that kind of thing that happened half a decade ago, however long ago. Like, some of those design patterns were never used, but we had the terminology to talk about things with people. And what the OWASP Top 10 gives us is terminology to talk about things. Like, oh, you've got broken access control. Here's this cheat sheet on what you should do to fix it. Or when someone talks about SQL injection, they're actually talking about the same thing that someone else might call, I don't know, string concatenation and execution or something like that, What else did I suggest? Oh, keep track of which things affect you. So it's quite fun to keep trend information in your own development teams. It's like cross-site scripting keeps biting us in the butt every time we build a new web application. I think it's time we pick a new framework that does escaping automatically. Or we've switched to a new way of doing database access. All of a sudden we're getting SQL injection attacks working against our application. And keep those trends and use that to inform your training that you do inside your company and to make better decisions. Yeah. So other things, there's a bunch of other meetups that happen in Wellington. Hunt them down. I think I put it in the RSVP email. There's a page on our meetup for other security-based meetups in Wellington. So there's ISIG, which is more InfoSec-y, hackery, pen testery. There's First Tuesdays, which is more C-level security management type people. NZITF is an industry collaboration group. I think there's a lockpicking club. So there's a bunch of different things going on in Wellington. And then also Wellington's the epicenter for security conferences in New Zealand, because we currently have, or sometimes have, KiwiCon, PurpleCon, KawaiiCon's kind of KiwiCon happen in Wellington, and the OWASP conference in Auckland. So there's lots of things you could do as your next steps. But hopefully you'll come along to another meetup where hopefully someone else will speak. So if any of you are interested, I can recommend having a deadline of 2 months to prepare a talk as being a really good motivator for learning stuff. So if there's something you'd like to learn and present on in 2 months, it's pretty low key. Yeah, let me know. Cool. Thank you all very much.
Thank you.
Oh, Is there any way to test if a field is vulnerable to SQL injection? The way I normally test if a field is vulnerable to SQL injection is just to put a single quote in, and if the website breaks, that's a pretty bad sign. Or you could try double quotes. Pretty much any time a character will break your website, it's a bad sign. Thanks for coming. You can just leave the rubbish on the table. It's cool. And the same with cross-site scripting. Like if you put an angle bracket, a less than or whatever, and the website looks yucky, then you've probably got cross-site scripting. Cool. Any other questions before I click end broadcast? Nick.
You mentioned someone got arrested after finding a bug in Citibank or in an Australian bank. Now that we know a bit about these, what should we do if we find a bug?
Well, you should arrest people. Oh, so you want me to say be responsible? Yeah, cool. So I haven't given you enough information to be an elite hacker, but hopefully you're now a little bit more curious about some web security things. So yeah, use this knowledge wisely. Turns out that it's less illegal to try these against your own websites than it is for other people's. Yeah, I don't think anyone in New Zealand's been arrested, but you know, the National Party hacked the budget by typing stuff into a search box. So you don't want to end up in the newspaper.
How do you usually test if you use how do you learn if you cannot?
Oh, so yeah, the question is how do you learn if you're not allowed to test other people's websites? So there are some training ones. So on the OWASP site, which I don't have open anymore, there are some projects, and one of them is Juice Shop, and there's some other ones, and they're examples of vulnerable websites. And so you can download these. I think this one you need to download, but I think there's a Docker image or something. But there's also online capture the flag. They call this style thing CTF, where you can try and find the security issues in websites. And because you've been given permission, you're less likely to get in trouble.
And bug bounties too. You go to hackerone.com or bugcrowd.com. People might give you a t-shirt or money if you find bugs on their site.
Cool. Do you have a question?
Secure code warriors. They have
that is a very good point. Secure Code Warrior is really good for developers to learn about looking for issues in source code. And what happens when you log in? I have a screenshot. Oh, there's a picture. Anyway, you log in and it gives you kind of a fake IDE and says which line has the security issue, and you have to try and find the security issue, and then it says, you know, which one of these 10 things is the right thing to do to fix it, and then gives you resources to learn about it. So yeah, thanks for bringing that up. Secure Code Warrior came to Wellington and did some training up at